All right. We have talked about centripetal force, and you went through the exercise of talking about changing each one of these items. And based on your answers, we're going to talk about my centripetal force. How does it relate to or is proportional to if I increase the mass, right? So if I put a different mass at the end of the string, what happens, right, to my centripetal force, right? It's directly proportional, right, to, if I increase the mass, I'm going to increase the force, centripetal force. What happens if I increase the speed, right? Well, it seems like if I increase the speed, not velocity, right? If I increase the speed, I'm also going to increase the force. Now, there's a little bit of variation on that one. And if I increase the radius, right, what happens, right? If I increase the radius, right, what happens to that centripetal force? And I want you to think about taking a turn. So if I take a turn, so maybe 15 miles an hour, I take a left-hand turn, and I take it kind of sharp, right? And I compare that to taking a right, or I guess a left-hand turn, and I take it kind of sharp, right? What happens to my passenger? If I go that same speed at a larger radius, right, what do I experience? If I increase the radius, right, my force centripetal actually goes down. So it's proportional to the inverse of the radius. If I decrease the radius, the force goes up. Ultimately, we get this equation. And this is the combination, right? Like this. Now, I'm going to go like this real quick. If I have a center-directed force, Newton's law says, meaning a net force, Newton's law says I have a net acceleration, or I have an acceleration in that same direction. So if I have a center-directed force, it means I've got a center-directed acceleration. My center-directed acceleration is going to be related to v squared over r, and it's kind of a complex derivation. But if I have acceleration because I have changing velocity. Now I might have constant speed, but velocity is magnitude and direction. Speed is a magnitude, but velocity has direction. So every time I rotate, my direction changes. So I have changing velocity, so I have acceleration. But this is my equation that I can do the math and physics to explore all sorts of different things. So there's going to be 2 sheets that you're going to work through, and at the end you're going to post something to show me that you've gone through it and watched the videos. The first thing we're going to explore is the question is mass impacts that centripetal force, but on the highway signs, right, they give us these caution signs, and they say like 45, I forget what they say, maximum speed 45, or off an on-ramp they might change it to 35. Well, why aren't they differentiating between mass? Or is this a speed for really big trucks? Or is this a speed for everybody? Right? When we go to Worlds of Fun, why do they have this finger, right? Right, this finger that says you must be so tall. Why don't they say you must be this much, or you must weigh this much? We're going to use this equation to talk about both of those. When we're on a turn, it's horizontal motion. We're going to look at the horizontal motion keeping us in circular motion. And then on roller coasters, and this is really mainly, well, it's not, it's for all of them because they have this circular motion and turns. But what about the ones that go upside down? Okay, so we're going to talk about those. Who falls out, the heavier person, the lighter person, or does it matter? Okay, so This is taking this concept of centripetal force and putting it into Newton's second law. The net force that's center directed equals mass times acceleration. Okay? So we'll work with those in the next video.